Hi guys, it's time to get back into logarithms, and it has been a while since we've done logs, so I'm going to go through some properties of logs, but if you're feeling like you don't even remember what a log is, then tomorrow in class we actually are going to do a little bit more review to get back into logs and what they are so that this will make some sense to you. But today what we're going to talk about in this video is the properties of logs, because just like, for instance, we have rules for exponents, we also have rules for logs. And so we're going to investigate what some of those are today. Would you take a minute to look at this text box here, this table, and fill in as much as you can of these two columns. So go ahead and pause it here and fill in what you can. Okay, what you should have gotten was x to the 5th, x to the 9th, and x to the 15th. And then over here on the right, we have the rules. And the rules are, if you're multiplying two exponents together, you add the exponents. If you're dividing, you subtract. And if you're taking a power of a power, you multiply. Now, I have a way that I remember this in my head, and I've shown this to you a couple times. I'm not sure if you remembered those, so let's go back over. Here's the deal. If you have parentheses or an exponent, like a power of a power, you multiply those two together. If you have multiplication, like this top line, we have multiplication, then we're going to add them together. And if we have division, like the middle section, then we are going to subtract. And so this is how I kind of keep it straight in my head, and then I'm going to use those same rules because we know that logs and exponents are inverses of each other. So they actually use the same rules. It's just they're opposites. So let's take a look at what I mean here. In this next section, I have some log properties, and I have some examples, and we're going to talk about how to break that up maybe. In fact, let's go ahead and say, if we're going this way, we are going to expand the logs. Now, what does that mean? Well, expanding means that you're going to break it up, and what we have here on the left, it can be broken up. And sometimes it's easier to deal with one that's broken up than one that is put together. Or sometimes it's easier to deal with one that's put together than it is one that's broken up. So we're going to go through these. Okay, so for the expanding, I have a multiplication. If I go back to my rule, multiplication goes with addition. And so what I'm going to do is I'm going to expand this. I'm going to break it up to say it's actually log base b of m plus the log base b of n. Because it's times here. If it's multiplication, that gives me addition. So I could also do it with an example. And on this example, you can also use your calculator for that to kind of figure it out. But what this is this is saying that log base 4 of 5 times 3 is actually the log base 4 of 5 plus the log base 4 of 3. And you might say, well, why would you even do that? Why wouldn't you just say the log base 4 of 15? Well, you might. But there might be times when it's easier to break it up like this. And so hopefully we'll get to some kind of word problem examples where that might be helpful to you. But this, like I said, this is one we could check on our calculator. Okay, so if I go to my calculator, I've gone to the calculator and I've tried, okay, what is the log base 4 of 5 times 3? What's the log base 4 of 15? And what's the log base 4 of 5 plus the log base 4 of 3? And you can see all three of those come out to be the exact same thing. But again, why we would want one rather than the other would just be different situations. It might be an equation that you're trying to solve. It might be a word problem that you're trying to solve. And maybe that word problem is better solved or easier to solve if you break it up. So that's kind of why we're doing this. So if I go back to the notes here, this time the next example is a division problem. When I have division, I'm supposed to subtract. So I'm going to have the log base b of m minus the log base b of n. And so if I had in numbers here, I could break this up and I could call this the log base 2 of 20 minus the log base 2 of 2. Or again, maybe just put them together and say the log base 2 of 10. So these are just properties. Just like we do with exponents, we sometimes need to combine them. We're doing the same thing here. Let's look at the next example. We have the log base b of m to the x. Now we have a power. When we have a power or an exponent here, if we have an exponent, we're supposed to multiply. What we're going to do is we're going to take that exponent and we're going to put it in front. So it's going to be x times the log base b of m. And so again, here we have this problem here, so I can rewrite this as 3 times the log base 5 of 15. And again, why would we want to do that? Well, think about, let's say you were doing this mentally, and we don't know how to do log base 5 mentally, but 15 to the third power, I have no idea what that is. But maybe I know what log base 5 of 15 is, maybe, and I can just multiply that by 3. So it just allows us a little bit of leeway to solve things in a different way. That's what we're doing here. So again, if we are going, let's go back up here to the top. If we are going from left to right, we are expanding. We're making them longer. That's what expanding means, right? So if you look at these problems, they're all really short, but we can expand them and write them in a longer way. But sometimes, for other purposes, maybe it makes more sense to go this way. That is, maybe we have this big long thing and we actually want to what's called condense it. And so if we're going from the longer version over to the shorter version, that's called condensing. And once again, why? Well, maybe you have this big long problem, but if you just put it together in one, maybe easier to solve. So I'm just giving you tools, different ways to use these logs to solve things. Okay, in our notes, in the next section, I go down to condensing, but since we just on the table, we learned expanding, I think it's going to make more sense to do the expanding before the condensing. So let's turn the page and go over here to some of these condensing examples, or excuse me, expanding examples. So again, the word expand means to make it longer. What that means is you're going to break up this log into several log expressions, but use the same log base for all of them. In other words, the question just has one log in it. Our final answer is going to have a couple of logs in it. All right, well, let's remember how to do this. So remember, we're going to use these Pemdas format. That's how I do it. That's how I remember it. And remember how to do this. So this is a division problem. Division means subtraction. So what that means is I'm going to have log base 5 of x minus the log base 5 of y. Notice I have two log words, like I have that word log twice over here. I only had it once over here. I'm emphasizing that because it should not be, and I'm going to write this down, but don't you write it down because I'm going to erase it. It should not be the log base 5 of x minus y. That's not the same. Okay, that's not what it is, because look, this is a division, this is a subtraction. So don't do it that way. You have to subtract the whole log, not just the numbers, but the actual entire log. All right, let's do another example. This time we have a couple of things going on. Remember when we learned exponents that what this really is this is 3 times r to the 4th. In other words, that 4 does not go on to that 3. It only is on the r. So this is a multiplication problem. Multiplication means we add. So we're going to have the log of 3 plus the log of r to the 4th. We can do it one more time because we have a power. And powers or exponents means you multiply. So what I really have is I still have that log base 3, and then I'm going to take this 4 and I'm going to put it in front here. And I'm going to have 4 times the log of r. So just remember with the exponent rules, that piece of it, but what I've got now is there were 2 parts that I was taking the log of, so I have 2 different logs. Okay, I don't think we have to do every single example, so I'm going to skip number 3 for now. Maybe we'll do that as a warm-up, or if we need to do it in class, we can. All right, let's look at number 4. Look at the difference between number 4 and number 2. Do you notice how on number 2, that 4th power was only on the r? But on number 4, that 2nd power is actually on both the y and the 3 because of those parentheses. So if we wanted to rewrite this as the natural log of y squared over 9, we could do that. One other thing with this problem, remember that ln? ln stands for natural log. And remember that the natural log and e are inverses of each other. And so that's what that natural log means. It really means the log base e. And again, it's been a while, so I'm sure people have forgotten that, but the natural log means log base e. But we just write it as natural log because it's a very common log that we use, and so that's how we write it. Okay, let's keep going. So we have a division problem. Division means subtraction. So we're going to have the natural log of y squared minus the natural log of 9. Division, subtraction. One more thing is this second power. Exponents, we multiply. So we're going to take that 2 and bring it out front, and we're going to say 2 times the natural log of y minus the natural log of 9. And then we're done expanding. That's as far as it can expand out. How do you know when you're done? Well, you look at what you have and you decide, is it taking the log of more than one thing? Then you might need to expand it. But in my answer, I have the log of one thing minus the log of one thing. Same thing up here. I have the log of one thing plus 4 times the log of one thing. But in my original problem, I had the log of 2 things. Okay, so that's how I know if you're done, or that's how you know if you're done or not. Again, let's keep going. Maybe number 6. We need to break this up. It's obviously a subtraction problem, but it's also a multiplication problem, right? So let's see what we're going to do. There's going to be 3 parts. Since there are 3 different letters, there's going to be 3 different logs. So I'm going to have the log of x to the 3rd plus the log of y to the 4th minus the log of z to the 5th. So that's where all 3 of those things that were multiplied, these are being multiplied, so it's plus. This is being divided, so it's minus. They each have an exponent, so the exponent needs to come out front. So this is going to be 3 times the log of x plus 4 times the log of y minus 5 times the log of z. And now I'm done. How do I know that I'm done? Because I have the log of only one thing. Log of one thing, log of one thing, so then I am done. I do want to look at number 7 just because it's a natural log, and I think that some people get confused with natural log. The process is actually very similar to number 6. It's even a little bit shorter. In fact, why don't you take a second right here to pause the video and see what you can do with number 7. Okay, you should have come up with a natural log of 3 plus the natural log of y minus the natural log of x. Now, if you look ahead at number 8, it's a little bit different. The different thing is the square root. Do you remember what power is a square root? Square root is the 1/2 power. And so I'm going to break this up. I'm going to say what I have is the log of r plus the log of the square root of 5 minus the log of s squared. The first one I'm done with. The second 2 have another step. So this is going to be the log of r plus, this is actually an exponent. Square root is an exponent. So this is going to be 1/2 times the log of 5. And log of s to the 2nd, once again, it's an exponent, so we put the 2 in front and the log of s after that. So that's your final answer. Okay, this page, like I said a second ago, this page deals with expanding. That is, taking a log, a single log, with a lot of stuff in it, and breaking it up. In this case, there were 3 things on the inside, so there were 3 different logs. Now, we also can go the other way, and oftentimes we will need to go the other way. So let's turn back to the other side again and do some of those examples. So this is condensing. The idea with condensing is to put it all into one expression with just one log. Now, you can only do this if you have the same log base. If this was like log base 3, but this was log base 5, you could not put those together. They have to have the same base. But all of the examples here that I have, I'm looking and double checking, all of the examples here do have the same base, and so that's possible to do. All right, let's take a look. We have two different logs. We want to put it together into one log. So we might just take a second to remember our PEMDAS. So we have a subtraction. What does subtraction mean? Subtraction, now we're going backwards, so subtraction means division. So we're going to put it together into a single log, just has one word in it. And we get the log base 3 of 20 over 4, or even better, simplify that down to log base 3 of 5. Okay, so that's my final answer. I've put it down into one log. All right, let's go to number 2. Do you remember what it means if there's a number in front? If there's a number in front with multiplication, multiplication means exponents. So this is going to be the log base 2 of x to the third. And then I have a plus and another log base 2, so I can combine those into a multiplication problem because addition goes up to multiplication and make that a y. And so that's my answer, log base 2 of x to the third times y, which you can write out this way if you like that better than this for whatever reason. Again, I don't think we have to do every single example, so let's look at number 4. What does a 1/2 in front mean? Well, first of all, the number in front, that's a multiplication problem. That means we go up and we make it into a power. So what is the 1/4 power mean? Well, let's just start to work this one out. We also have an addition problem. Addition means multiply. So what I really have here is I have the log base 3 of 2 to the 1/4 power times, and then I have another 1/4 power, and I have an x, so this is x to the 1/4. Or in other words, I have the log base 3 of the 4th root of 2x. Okay, because the 1/4 power means the 4th root. And then those I can just put together, and I get this as my answer here. Number 3 is a lot like number 5, so I think I'm going to do number 5, but then also we will do number, there's two number 5s. So this number 5, true, but let's call this one number 6, because that's actually which number it is. And I'm going to do number 6 because it's pretty simple and goes very quickly along with number 4, and then we'll come back and do number 5. In fact, why don't you see what you can do with number 6? Okay, as I look at number 6, there's a lot going on, right? And there's several different ways to do it, because when I did it just now, I did it this way. When I did it about 10 minutes ago, I did it a little bit differently. But what you have here is you now have the natural log of, now 3 squared is 9, and that came because it was a 3 here and a 2 here. So we take that 2 and we make it into a power. And then the 1/2 power of 4 means the square root of 4. And then I have a square root of 9, and that makes 3. So really, my final answer is the natural log of 27 over 2. Now, you might have come about that a little bit differently, because there's a lot of different ways you could have done that order-wise. But the final answer should be this. Let's take a look at number 5, and the main reason I'm going ahead to do number 5 is there's these parentheses. You can deal with that parentheses in a variety of ways. Probably most people see those parentheses and they want to do this. That's good. Let's just do that. Okay, so I've got this when I distribute that 1/2. That 1/2 means power, right? It's a multiplication, so it's an exponent, so it's a power. Power of 1/2 means the square root. So what I really have is I have the log of the 1/2 power of 4, that's 2. I have a plus, that means I want to multiply, and I have the square root of y, and then I have minus, that means over, z to the third. And so this log is taking the log of this whole thing. And that's how I would leave it, as the log of all of this. And I put those extra parentheses in there. You probably don't need some of those, but I'm showing you that all of that is taking the log of that. And back to, how do I know when I'm done? Well, we are condensing here. And when you condense, you want it just to have just one log. And so on number 5, I put all that together and made it into a single log. That is condensing. All right, that's a lot of information. I know that a lot of times the rules, because they're rules and you really just have to memorize them, they do get a little difficult. So what I want you to do to help your brain remember it is to write down a summary. Write some things down that you need to remember, because basically you do need to memorize this. So let's go ahead and write down some of it so we can start to put it into our brain better. And then we are done with the notes. We'll do a lot of examples on this in class tomorrow, so we'll get some extra practice. Please write down any questions you have. Write them in the margins. As you are working through this, write through questions in the margins so that we have those.